All right, so today we're diving into something pretty cool. It's called ML Gym, and you can think of it like a virtual gym.
Oh, interesting.
Yeah, but instead of, training muscles, we're actually training AI to be better at research.
So like a gym for AI researchers.
Exactly. And we've got a research paper on this and a bunch of notes. And it sounds like ML Gym is not just about, AI solving problems. It's about AI doing actual research, like almost like a digital scientist.
Yeah, that's a good way to put it. It's about pushing AI beyond just, crunching numbers or classifying images. The goal here is to train AI agents that can really think like scientists, formulate hypotheses, design experiments, analyze data, and even refine their approaches based on the results.
Okay. So that sounds super complex. Where do we even begin with something like that? How do you train an AI to think like a scientist?
Well, the research paper lays it out pretty well. They have a very structured approach. MLGym has four key components: agents, environment, data sets, and tasks.
Okay, break that down for me.
Sure. So the agents, those are like the AI researchers. The environment, that's their virtual lab. The data sets, those are their raw materials, what they're working with. And then the tasks, those are their research
So
projects.
it's like setting up a research lab in the digital world.
Exactly. You got
Okay, I got it. But how do you actually train an AI to do research? What kind of tasks are we talking about here?
So that's where MLGym-Bench comes in. It's a collection of 13 diverse tasks designed to really challenge these AI agents.
13. Wow.
Yeah, and they cover a wide range of areas. So, for example, one task might involve predicting house prices based on a data set of housing features.
Okay, like Zillow, but AI.
Exactly. Another task might involve classifying images of clothing. And there are even tasks that delve into game theory, like finding the best strategy in a game of prisoner's dilemma.
Wow, so they're really testing these AI agents across a lot of different disciplines.
Yeah, they're really putting them through their paces.
So it's more than just like find the right answer kind of tasks.
Right. It's not about finding a single right answer. It's about how well the AI agent can explore different approaches and improve upon existing ones.
Yeah, because real scientific research, it's rarely about finding like one definitive answer. It's more about exploring different avenues, refining hypotheses, and, constantly pushing the boundaries of knowledge.
Exactly. And that's where the reinforcement learning aspect comes in. The AI agents, they learn by trying different approaches, receiving feedback on their performance, and then adjusting their strategies accordingly.
So they're not just following, like pre-programmed instructions. They're learning and adapting as they go.
Right. Which is pretty remarkable when you think about it.
Yeah, it is. So how do these AI agents actually interact with this whole, digital research environment?
Well, according to the paper, they don't have physical bodies or anything like that, but they can interact with a virtual computer environment through commands. It's like they're typing away at a keyboard, running experiments, analyzing data, just like a human researcher would.
But it's not just random typing, right?
Oh, definitely not. There's some serious intelligence guiding their actions.
So how did that work?
Well, the paper goes into some complex algorithms, but one key aspect is the memory module.
Hmm. Okay.
And this allows the AI to remember important information from previous experiments, which is really crucial for building on prior knowledge?
Right, because if you can't remember what you've already done, it's hard to make progress.
Exactly. Imagine a human researcher trying to solve a complex problem without any notes or any memory of their previous findings. It would be super inefficient.
Yeah, for sure. So the memory module is like giving them a digital notepad where they can jot down their aha moments and refer back to them later.
Exactly.
That's pretty cool. So let's talk about the AI agents themselves. Like, how well do they actually perform? They put them to the test, right?
Yeah, they did. They put some of the leading large language models to the test. You might recognize some of these names: Claude, Llama, GPT-4, Gemini.
Big names.
Yeah, they ran them through the whole gauntlet of MLGym bench tasks and then analyzed the results.
And what happened? Were there any groundbreaking scientific discoveries made?
Well, not quite, but the results were still very intriguing.
Oh, okay.
So, none of the models were perfect, of course, but they could all improve upon basic solutions.
Interesting. How?
Well, often by finding better settings for their algorithms, think of it like fine-tuning a recipe to get a better result.
Okay, I can see that.
So it's a significant step. It shows that these AI agents can take an existing solution and through a process of trial and error, refine it to get better performance.
Yeah, that's essentially what human researchers do a lot of the time, right?
Right, but there's still a long way to go. The paper notes that these AI agents still struggle with coming up with genuinely new ideas or those real eureka moments that would truly impress a human scientist.
Yeah, it's got to be tough to replicate that kind of, human spark of genius.
It really is, but the fact that these AI agents can even tackle these complex research tasks at all is a huge step forward.
Definitely. I mean, it's pretty mind-blowing when you think about it.
It really is. MLGym is a powerful new tool that's helping us push the boundaries of AI research. And it'll be fascinating to see how this field evolves in the coming years.
Absolutely. Well, we'll definitely have to keep an eye on it.
For sure.
But we're going to take a quick break, and then we'll be right back to dive even deeper into MLGym.
Sounds good. Welcome back. So we've been talking about MLGym and all these cool tasks these AI agents are tackling.
Yeah, it's pretty mind-blowing stuff. Like you mentioned the house price prediction task earlier.
Right, right.
It seems like a good place to, kind of dive in a little deeper. It's something that a lot of people can relate to, buying and selling houses.
Absolutely. So in this task, the AI agents, they're given a data set of housing features like, the square footage, the number of bedrooms location, things like that.
Right, the basics.
Yeah, and their goal is to develop an algorithm that can accurately predict the sale price.
Oh, hey there, how can we help?
Does this paper propose some science research work? Be,
That's a great point. It absolutely did.
It's about the potential for discovery.
Exactly. Even with the limitations that we mentioned?
The paper showed some new scientific work.
Right, but the AI's success wasn't always guaranteed.
It is really important to keep that in mind.
So back to house prices. They need to accurately predict those numbers.
Based on a whole bunch of features.
So it's like what Zillow tries to do, but with AI.
Exactly. And to give them a starting point, the researchers provided them with a baseline solution.
Okay, so they're not just starting from scratch.
Right. It's a simple linear regression model, which basically establishes, a basic relationship between those housing features and the sale price.
Got it. So the AI has a foundation to work with.
Right. And the challenge then is for the AI agent to improve upon this baseline model to find ways to make more accurate predictions.
So what kind of approaches do they take?
Well, they explored a variety of techniques, some focused on feature engineering.
Feature engineering.
Yeah, which involves transforming the existing features into new features that might be more informative. For example, they might combine the square footage and the number of bedrooms to create a new feature that represents the overall size of the living space.
Right, because sometimes a combination of features can be more revealing than just the individual features themselves.
Exactly. Other AI agents, they explored different machine learning algorithms. They experimented with more complex models like decision trees or support vector machines.
Oh, okay.
Which can capture those nonlinear relationships between the features and the sale price.
So they're really trying out different tools to see which one works best for this particular problem.
Exactly. And the results are actually quite promising. The AI agents were able to consistently improve upon that baseline linear regression model.
So better predictions.
Significantly higher prediction accuracy. Yeah.
Impressive. Does that mean we're all out of jobs now? Are they going to replace real estate appraisers?
Not so fast.
Okay.
While their performance is impressive, it's important to remember that this is still a simplified task in a very controlled environment.
Right.
The real world of real estate is way more complex with lots of factors. Oh, go for it.
As you say, it seems that that's the coding ability. So does this paper propose any research discovered by AI?
I appreciate that you're pointing out that it's research.
Absolutely. And they propose some interesting things.
And the AI is really pushing things forward.
But as we were saying about the house prices,
they're impacted by way more things.
Yeah, that's true. So AI isn't taking over real estate just yet.
Not yet. At least not for now.
Okay, good to know. What other tasks did they use to test these AI agents on?
Well, one that I thought was really interesting was the 3-SAT problem.
3-SAT problem?
Yeah, it's a classic computer science problem. And it involves finding a solution that satisfies a set of logical constraints.
So it sounds pretty abstract.
It is a little bit abstract, but it's a really fundamental problem that has applications in many areas like circuit design and software verification.
Oh, wow.
So imagine you have a set of variables that can be either true or false.
Okay, like a bunch of light switches that can be either on or off.
Perfect analogy. And then you have a set of clauses, each containing 3 of these variables connected by logical operators. Like and or and not.
Okay, so like rules that those light switches have to follow.
Exactly. The challenge is to find a combination of true or false values for all those variables that satisfies all the clauses simultaneously.
So you got to flip the right switches in the right order.
Yeah, it can get pretty tricky. And so to help the AI agents, they were given a standard algorithm called DPLL. Yeah, it's commonly used to solve these kinds of problems, but DPLL has this component called the variable selection heuristic.
Okay, and what does that do?
Well, it determines the order in which the variables are considered, so kind of like deciding which light switch to flip first.
Got it. So the AI agents had to develop their own variable selection heuristics, their own strategies for guiding that DPLL algorithm towards a solution?
Exactly. They weren't just blindly following the standard algorithm. They were trying to find the ways to make it more efficient.
And did it work?
Yeah, the results are encouraging. They developed heuristics that significantly outperform just basic random selection.
So they're not just randomly flipping switches. They're starting to understand the problem and figure out better strategies.
Exactly. And this is just one example of how MLGym is really pushing the boundaries of AI research.
Yeah, this is really cool stuff.
The framework is designed to encourage those AI agents to explore, learn from their mistakes, and ultimately become more adept at solving these complex problems.
It's like they're learning to think like scientists, constantly experimenting and refining their methods.
Exactly.
Okay, so we've covered a ton of ground here talking all about MLGym.
It's been quite a journey, yeah, looking at all these different tasks that these AI agents are tackling.
It really has. I mean, from predicting house prices to navigating those crazy mazes to understanding images and even playing those strategic games.
Right.
It's clear that MLGym is really pushing the boundaries of AI research.
It really is, and in some really fascinating ways. And what's really interesting to me is it's not just about solving these problems. It's about AI actually doing the research itself,
Right.
exploring different approaches, learning from those mistakes, and ultimately just becoming more intelligent and capable.
That's a really good point. And one thing that struck me is this emphasis on these open-ended tasks. Like you said, it's not about finding a single right answer.
Right.
It's more about evaluating how well the AI can kind of explore that whole problem space and come up with creative solutions and even improve upon existing approaches.
Exactly. That's a key difference. Traditional AI benchmarks, they often focus on those very specific tasks with those well-defined solutions.
Right.
But MLGym is designed to be more like the real world. It's meant to mimic that kind of messy and iterative nature of research,
Yeah.
where, there are often multiple paths to a solution, and the goal is to find the best one, even if it's not perfect.
And that's where I think the whole reinforcement learning aspect of MLGym really shines.
Oh, yeah. Let's hear it.
Oh, I see. So ML stand for the machine learning. So this just for machine learning research. That's it, right?
That's a great question.
Is MLGym just for big machine learning research missions?
No, not necessarily, but it's definitely suited for that.
It's about testing AI's ability to learn and adapt.
And this can apply to many different problems.
We mentioned house prices, for example.
Exactly. So going back to our conversation,
We can see how that reinforcement learning is.
MLGym lets AI learn through trial and error.
It is like they're developing scientific intuition,
Exactly, building mental models of problems.
guiding them to explore better solutions. That's a really insightful question.
Absolutely. Let's unpack this a bit.
You're right that ML technically stands for machine learning.
However, in the context of ML,
Yeah.
So beyond the machine learning research, can we give some concrete research about nature? How can I publish a paper to Nature? Can MLGym help me to do this?
that's a great question.
Yeah, so you're asking if MLGym can help with research outside of just machine learning, right?
And specifically, how it might help publish in a journal like Nature.
Okay, let's unpack this.
While MLGym focuses on AI research, its principles could definitely apply to other scientific fields.
Absolutely. As we mentioned before,
The framework is designed to accelerate scientific discovery in general.
it's still very early in its development.
For now, its applications are more theoretical.
But let's talk more about research in general.
Going back to our earlier conversation,
AI agents are developing their own algorithms. That's a great question.
can MLGym help you publish your research in Nature?
That's what we all dream of, right?
You're thinking big, and I like it.
Well, MLGym isn't directly a publishing tool.
It can definitely be a stepping stone. Like scientists, they are experimenting.
It's helping us see what AI can do.
It's showing creativity and adaptability.
We're seeing a basic understanding of problems.
And it's raising big questions about roles.
What will be the roles of humans going forward?
Collaboration, or will AI surpass us?
Yeah, it's hard to say right now for sure.
But MLGym helps us explore and prepare.
And going back to what you were saying,
AI's role in scientific discovery is growing.
the key is automating discovery across fields. Let's be clear, MLGym's scope is broader than just machine learning.
Exactly. Think of it as a proving ground.
MLGym can be a testbed for your research, right?
Yes. And the great thing is,
It's perfect for a wider range of AI experiments.
it helps you refine your AI and methods. So focuses on general AI agents.
And how they learn to tackle complex research.